Hello my friends and welcome to this new practical activity on this time the Kernel SVM model. So in the previous section we implemented the classic SVM model, meaning the support vector machine with a linear kernel, and now we're about to see what we get with a nonlinear kernel, like the radial basis function or another one. So that will be very exciting, and mostly what will be very exciting to see is if we manage to beat the previous accuracies we got previously. I remind that the best one we got so far was 93% from the KNN model, and now let's see if by adding a nonlinear kernel to the SVM, well, we get a better accuracy than that. Great. So, as usual, I want to make sure that everyone here is on the same page. I gave you the link to this folder in the previous tutorial in the article, so make sure to connect to it. And if that's the case, well, please follow me into part 3, classification, to implement the kernel SVM model. And as usual, we're going to start with Python, and here we are with our two files. The first one that contains the whole implementation of the kernel SVM model in the IPYNB format, and the second one, the dataset, that same dataset on which we trained and will train all the classification models of this part. So let's have a quick look at it again. This dataset contains some information of 400 customers represented by each row here. So each row corresponds to a customer, and for each of these customers, well, we have the age, which is the first feature, the estimated salary, which is the second feature, and the dependent variable purchased, which tells whether or not they bought no or yes a previous SUV. Alright, and so in our practical activities of this part 3 classification, we build several classification models to understand the correlations between these two features here and this dependent variable purchased in order to predict which future customers will buy brand new luxury SUV that is advertised on social networks. Alright, so still the same story, and now, well, let's begin our kernel SVM implementation. I'm going to open it with Google Collaboratory, but you have the choice to open it with Jupyter Notebook as well. Choose your favorite, and now it is opening the notebook, loading it, laying it out, and there we go. Welcome to the kernel SVM implementation. Alright, and of course it results from the exact same classification template which we made in the first section of this part, Logistic Regression. Indeed, when we built the Logistic Regression model, we made at the same time a great classification template which allows us to only change one cell when building another classification model, which is exactly, the cell where we build and train this classification model on the training set. So this cell is the only one we have to modify here. However, this notebook is in read-only mode, so in order to modify this cell to build a kernel SVM model, we have to indeed click File here in order to create a copy of this notebook. And to do this, you just need to click Save a copy in Drive. This will create a copy of this notebook, and in a second, you'll have it opened on your machine. Alright, so I'm going to put everything in that order. Alright. And now this is our copy, and so inside the only thing we have to re-implement is indeed that cell where we build and train the kernel SVM model on the training set. So let's not look at it, let's put it in the trash, and now let's re-implement it from scratch. Alright, perfect. So it's actually super easy. We can even do it even more efficiently than the usual way when we went to the scikit-learn API, then got the name of the function, because as I explained in the previous section when building the SVM model, the classic one, well, the way we built it was actually to, build an object of this class, SVC, and then choose a linear kernel. And now, actually, we're about to do the same. We're about to use the same class to build this kernel SVM object, but this time instead of choosing a linear kernel, we will choose a nonlinear one, and that's the best example of it, the most commonly used. It is the RBF radial basis function kernel. And you also have some other ones like the polynomial kernel or the sigmoid kernel, but really this one is the best option to start with. And that's the one we'll choose for our kernel SVM implementation, as you might have guessed. And therefore, remember how I also want to train you on how to juggle with the different tools of your machine learning toolkit, the data preprocessing toolkit or the regression toolkit, or even now the classification toolkit containing all your classification models. The most efficient way now to build this kernel SVM model is just to go back to our SVM implementation, then find that cell where we built the SVM, And indeed, since we built that SVM with the same class SVC, but choosing a linear kernel, well now, as simple as that, in order to build our kernel SVM, we just need to take this code cell and paste it right here in a new code cell, and then guess what? Just change that kernel parameter. All right? And as we said, this time we're not using a linear kernel, we're going to use an RBF kernel, the radial basis function, which was explained in the intuition lectures. And there you go, my friends, that implementation is over. You see how I'm doing all these templates to make you as most efficient as possible? Well, that's what I mean. Now we can juggle between our different codes, different tools of machine learning, and we can build new models in Flashlight. And that's what we just did with Kernel SVM. All right, so basically we're done, we're ready. So the next natural step is to upload the dataset inside the notebook. And to do this, you need to click this folder button here. Then your notebook will be connecting to a runtime to enable file browsing. Still the same story. In a few seconds, we should be able to see the upload button. Perfect. There we go. And so now we're going to click it, and we will directly get access to social network ads if you were here in the SVM section. But let me show you the path once again. So please find first your whole machine learning AZ folder. Then please go to part 3. Then section 17 kernel SVM. Then Python. And then social network ads.csv. Perfect. It will upload the dataset inside the notebook. And now we can run everything by clicking runtime here and then run all. Run all. This will run all the cells, including this one, which will get us the new model with the new nonlinear kernel. Where is it? Right here. Kernel equals RBF. And so now it's very interesting because this time we have a nonlinear classifier. And therefore, I look forward to showing you the visualization results at the end, both for the training set and the test set, because you will see that we will get a super beautiful curve that will catch the right observation points, the right red customers in the right red region and the right green customers in the right green prediction region. Not all of them, of course, but the ones which couldn't get caught properly by the previous, linear model, such as the support vector machine or the logistic regression model, right? Remember this straight line? This straight line could not catch these customers properly in the right green region, and these ones as well. And so you will see that now we will get much better results. But first, because right now I think it should be loading, running the code, yes. So we don't have yet the final result, but that's okay. Let's observe the different predictions. So first, our kernel SVM was perfectly able to predict the right result here. Remember, with that customer of age 30 and estimated salary $87,000, who in reality didn't buy indeed any SUV, and here we get the same prediction. So that's all good. Then let's look at the test set results. All right, so let's scroll back up a bit. So that's the test set results, and well, once again we have many correct predictions. An incorrect one here. The real result is 0, meaning that in reality this particular customer didn't buy the SUV, but our model predicted that this customer bought the SUV. Then we have the same incorrect prediction here, then all correct, all correct. It looks very good. Here we have an incorrect prediction, the inverse one. In reality, the customer bought the SUV, but our model predicted that the customer didn't buy the SUV. Then all correct, all correct, all correct. It looks very, very, very good, right? I really wonder if we can beat this accuracy. And that's what we're about to find out right now with, the confusion matrix. Are you ready? Are we going to beat the so far best accuracy we got, which was, I remind, 93% from the K nearest neighbor model? Here it is, 93%. And now let's see if we manage to beat it. All right, let's scroll down, and the accuracy is 93% again. Okay, so we didn't beat it, but we reached the same level as the KNN. And now let's see if we get the curve. No, still not. All right, it's still running. That's because we have a small step here, 0.25. If you want this to run faster, you can actually increase the step to 0.5 or even 1, but you'll get a less smooth curve, less nice curve. But that's okay. So, just in case it will get us the results in a few minutes, a too long time, well, let's maybe have a look at them in the original implementation, which is right here, okay? Just let's do that. Let's observe the final results, and here they are. As you can see, we get a super nice prediction boundary curve that catches this time perfectly well those green customers who couldn't get caught properly by the linear classifiers, with the straight line. This time it is catching them perfectly well, except these ones, of course, because they're trapped in the middle of many red customers. But these ones, which couldn't be caught properly by the logistic regression model or, the SVM classifier, right? If we have a look at it again, remember that the customers here couldn't get caught properly because of that straight line. But now that we have a curve, oh, there we go, we have the results. Now that we have this curve, well, these same customers, these are exactly the same one, these same customers are now caught properly in the green region. And same for these ones actually, these ones are caught in the right green region by very short. And same for these ones, and here, these ones are incorrect predictions. But once again, that's totally fine. We want to avoid overfitting anyway, because indeed, what's mostly important are the results of the test set, which we still don't have. It is still running, but we should get them in a second, or, let's just have a look at them right here. So now the challenge is to see whether we have the same results on new observations, meaning on observations with which our model wasn't trained. And that's exactly the observations of the test set, the 100 customers of the test set. And well, wow, here now it looks even better, which makes sense, right? Because we had 93% accuracy, and since there are 100 customers in the test set, we actually have 93 correct predictions and 7 incorrect predictions. And we can actually count them here, the 7 incorrect predictions. You have the 2 first ones here, the red customers falling in the wrong green prediction region, then these 2 here, 2 other red customers falling in the wrong green prediction regions, and then these 3 green customers falling in the wrong red prediction region. But that's totally fine. Once again, thanks to this beautiful curve here, we managed to catch these customers in the right region, which couldn't be the case previously because of the straight line resulting from the linear classifier. But this time, there we go, we have a non-linear classifier, which is the reason why we have this curve, and that's why we get a better accuracy. All right, so I'm at the same time very happy and excited because this curve is beautiful and we got great results, but I'm still hoping that with a future classification model, like the 3 ones we have left, we can beat that 93% accuracy, which we got so far as the best ones by 2 models, the k-nearest neighbors and the Kernel SVM. So I can't wait to see you in the next section, the next practical activity, to build this time the naive Bayes classification model to impatiently find out if it's going to beat 93% the accuracy of both the KNN and the Kernel SVM. So I look forward to seeing you in this next practical activity, and until then, enjoy machine learning.